Hello, welcome back. Let's read some more. This engine, that's a Russian jet engine from a MiG-31 jet fighter. It's a little bit hot in my apartment because the sun is shining. I like to read about the MiG-25. Do it after this. But let's read this. Try to keep the video in one part. Yes, I need a minute to go to my bed.
Solovier D-30. D-30 type turbofan national origin Soviet Union manufacturer Solovier Design Bureau first run 1963 major applications Tupolev 2134 Tupolev 2154 Mikoyan MiG-31 Ilyushin Il-76 Ilyushin Il-62 Sukhoi Su-47 developed into Solovier D-30K. The Solovier D-30, now the Aviadvigate LPS-30, is a Soviet two-shaft low-bypass turbofan engine, officially referred to as a bypass turbojet. It is probably the single most important turbofan engine developed in the Soviet Union. Development of the turbofan spurred numerous growth versions with increased fan diameter and modified component arrangements. Developed in a short period of time, about 3 years, the D-30 turned out to be one of the most reliable engines in the history of Soviet engine development, and it was recognized with the USSR State Prize. 1. Design and development. The original version of the Solovier D-30 was developed specifically to power the Tupolev Tu-134 short to medium-range jet airliner. However, it also served as a base for the development of a family of advanced engines. Engine development was started in the early 60s. By 1966, the engine was put into serial production. 1. The D-30 engine has a two-stage compression spool, a cannula combustion chamber and a four-stage turbine and was the first Soviet-built engine to use cooled turbine blades. The turbine was manufactured using the newest heat-resistant material of the time, along with an exhaust nozzle with a lobe mixer. The technical and efficiency parameters of the D-30 were competitive and similar to those of the Western engines of the period. 1. In 1969, an upgraded version, the D-30 Engine Series 2, was created. The main difference being the addition of a thrust reverser and an improved control system. The engine was produced in 1970 through 1987 and was used on the Tu-134FA, Tu-134B, and Tu-134AK aircraft. 1. In 1980, the D-30 Engine Series 3, a further improvement, was created with the maximum thrust of 6,930 kgf. With preserving it at up to equals plus C. The number of the engine compressor stages was increased to 5. The gas dynamic stability margin was improved. The system was introduced that protected against engine overspeed and gas temperature overheating. The D-30 engine of the third series was produced between 1983–1993. These engines were installed on the Tu-134A3, Tu-134B3, and Tu-134UBL passenger airliners. The core of the third series D-30 was also taken as a base point for developing gas turbine plants for the Russian fuel and energy complex. 1. The Solovier D-30 was produced in various modifications at the Perm engine plant, now JSCUECPM. In total, There were about 3,000 units of D-30 engines, Series I to III, manufactured in this engine plant. 1. Variants. D-30Ku. The D-30Ku engine is capable of generating 11,000 kgf at takeoff and was developed in 1971 to replace Kuznetsov NK8-4 engine on the Il-62 long-haul airliner, which had some difficulties covering intercontinental routes because of its inadequate range. Ilyushin Design Bureau. The aircraft designer made the decision to power the aircraft with newer engines which have lower specific fuel consumption. In contrast with the base D-30, the D-30Ku has increased bypass ratio and higher turbine inlet temperature. Its development was comparable to Pratt & Whitney's development of the JT8 D200 series, but with an even greater increase in thrust. The first compressor spool has 3 stages. The second one has 11 stages. The design of the combustion chamber is however similar to that of D-30. The turbine hop section has a total of 6 stages. The nozzle is common for both flows and has a lobe mixer and a mixing chamber. The D-30Ku engine was the first aviation engine in the USSR to include a bucket-type thrust reverser. The Il-62 aircraft equipped with D-30Ku had a range extended by 1,500 km, compared with the basic model equipped with NK8-4 engines. A total of 1,584 D-30Ku engines were manufactured by Rybinsk Engine Plant, now PAONPOUEC Sutton, under the authorized supervision of the Perm Design Bureau. 2. D-30KP. Similar to the D-30Ku, a new engine variant called D-30KP which delivered 12,000 kgf of thrust was developed for military transport aircraft Il-76. The development was completed by the end of the 60s. In 1971, Il-76MD with the propulsion unit on the basis of 4 D-30KP was demonstrated to the country's leaders. In 1972, engine passed certification tests and then was presented to the public at the next International Air Show in Le Bourget, France. By 1974 the engine was put into service to power not only military Il-76 itself, but also numerous modifications, tanker plane Il-78, aircraft hospital Il-76MD Scalpel, early warning and control aircraft of 50, weightlessness simulator Il-76K, airborne test rig Il-76L4 in-flight tests of the aircraft engines and others. D-30KP was identical to its predecessor D-30Ku, both are low bypass turbofan engines. The engine differs only by having a higher gas temperature at the turbine inlet and an increased compressor pressure ratio and bypass ratio. Powered by 4 D-30KP engines, Il-76 is capable of lifting a payload of 40 tons, 88,000 pounds, over a range of 5,000 kilometers, 2,700 mi, 3,100 mi, at cruise speed up to 900 km forward/hour. D-30KP engines were manufactured in the city of Rybinsk, Yaroslav region, at Rybinsk Engine Production Plant, now NPOUEC Sutton. The D-30KP engine's production continues till present for military supplies. More than 4,700 D-30KP engines have been manufactured in total. 3. The Chinese 11 and Y-20 prototype was also powered by 4 D-30KP2 engines. 4. D-30Ku-154. The successful replacement of the engines on long-haul Il-62 stimulated the leaders of the Ministry of Aviation Industry in the Soviets to re-engine another popular aircraft, the medium-haul passenger airliner Tu-154. Ultimately, Tu-154M powered by D-30Ku-154 was the backbone of the civil aviation industry in the Soviets till the end of the 20th century. The D-30Ku-154 engine was developed with a maximum thrust of 10,500 kgf specifically to power the Tu-154. Development started in 1979. Pavel Solovyov used the D-30 Ku core as a starting point. In the course of designing the D-30 Ku-154 engine, some of the systems were improved, new components were added, and in 1984 the new engine entered serial production. Their placement of Kuznetsov NK8 engine with the D-30 Ku-154 engine on Tu-154 allowed the reduction of fuel consumption by 28%. 5. This ultimately defined the profitability of the air transportations industry in the Soviets for another 15 years. During the years of active operation of D-30 Ku-154, the manufacturer Perm Design Bureau continued working on improving the engine. A vivid example of that is their development of the noise suppression system with noise-absorbing structures from polymer composite materials. There were in total more than 1,500 D-30 Ku-154 engines manufactured by Rubinsk Engine Plant, now NPOUEC Saturn. 5. D-30 F6 in the mid-1970s, the Soviet Union began the search for a high-speed interceptor to supplement and replace its MiG-25. The MiG-25 had two enormously powerful Tumansky R-15 turbojets, allowing Mach 3 speed at high altitudes. But the problem was their weak performance at low altitudes, not even sufficient to cross Mach 1 boundary. More acute problems stemmed from the tendency of the Fox-Bats engines to break down at maximum throttle in high-speed situations. A new engine, this time a low-bypass turbofan, was needed to power the new interceptor. The Mikoyankovic, MiG, Design Bureau contracted OKB-19 Design Bureau, now part of Aviadvigatel, to build such an engine for the aircraft that would become known as the MiG-31. The Soloviev Design Bureau came up with the D-30 F6 turbofan. Capable of generating 9,500 kgf, 20,900 lbf or 93 kN, dry thrust and 15,500 kgf, 34,200 lbf or 152 kN, afterburning thrust. The engine gave MiG's new interceptor a top speed exceeding 3,000 km per hour, 1,900 miles per hour, and a maximum takeoff weight of 45,800 kg, 101,000 pound. These powerful engines also allowed the large and complex interceptor to attain supersonic speeds at low altitudes under 1,500 m, 4,900 feet. Data from Aircraft Engines of the World 1976, James All the World's Aircraft 1993-94, 7. Other variants D30V12 high altitude version for the Musishk M55 rated to 49 kN, 11,000 lbf, 8. D30F11 engine for experimental twin engine S37, Su-47, prototype, 8. D21A1 another variant of the two-spool engine with supersonic nozzle intended to power high-altitude supersonic business jet S21 from Sukhoi Design Bureau. Construction scheme is almost the same as for D30 F6 except for the absence of afterburner chamber. 8. WS-18 Chinese reverse-engineered copy of imported D30 KP2. Applications. Ilyushin Il-62 jet airliner. Mikoyankovic MiG-31 jet interceptor. Sukhoi Su-47 Burkut, formerly S-37, demonstrator jet fighter. Tupolev Tu-134 jet airliner. Tupolev Tu-154 jet airliner. Ilyushin Il-76 strategic airlifter. Zion H-6 jet bomber, WS-18. Zion Y-20 strategic airlifter, WS-18. Specifications. A Solovier D-30 to Model 30 II D30 Q154 D30 KP2 compressor, 9, 10, axial fan, 4-stage ELP compressor 10-stage compressor axial fan, 3-stage ELP compressor 11-stage compressor axial fan, 3-stage ELP compressor 11-stage compressor combustor, 9, 1, cannula with 12 flame tubes turbine, 9, 10, 11, 2-stage H turbine, 2-stage L turbine 2-stage H turbine, 4-stage L turbine 2-stage H turbine, 4-stage up turbine thrust 66.68 kN, 14,990 lbf, 103.02 kN, 23,160 lbf, 117.68 kN, 26,460 lbf, dry weight 1,546 kg, 3,408 pound, 2,305 kg, 5,082 pound, 2,640 kg, 5,820 pound, with reverser, 3. Thrust to weight ratio 4.45 4.565.21 length, 11, 3,983 mm, 156.8 in, 1, 5,698 mm, 224.3 in, with reverser, 5,448 mm, 214.5 in, with reverser, specific fuel consumption, cruise. Kilogram forward / kg FHR 11 0.781 1 0.7050.715 fan diameter 963 mm 38 in 1 1,455 mm 57 in 12 1,455 mm 57 in 3 bypass ratio 11 1 1:12.50:12.24:1 overall pressure ratio 9 18.617.1 13 20.1 10 turbine inlet temperature K 1360 1 1336 5 1427 3 see also comparable engines Kuznetsov NK8 Pratt & Whitney JT3D Pratt & Whitney JT8D Rolls-Royce SPI Related lists List of aircraft engines References
Good. That was the engine from the MiG-31.